Good morning, everyone. Is it visible? Is it visible? Hello. Hello.
Yes, sir.
So, biochemical transducers. Today's topic is based on the biochemical transducers. Now, these are designed basically to measure the concentration of an ion or of a certain gas which dissolved in blood or some other liquid. So normal method is that one electrode used is that is used mm, as a one so that is used to sensitive to that substance or ion that is being measured, and another electrode or second electrode which is used that is insensitive to that substance or the ion which is being measured. Now the which is sensitive the which electrode which is sensitive to that substance or ion being measured is called the active electrode or indicator, and the second one which is called the reference electrode that is insensitive to that substance. So there are certain electrodes like reference electrode, pH electrode, uh, Blanch gas electrode, and specific ion electrode. So I'd like to discuss one by one. Move on to the next slide. Now, in case of reference electrode, normally hydrogen is used as a reference electrode. Why? Because like hydrogen gas or hydrogen ion interface that has been designated as the reference interface, and that was arbitrarily assigned, and electrode potential of 0 volts. For that's why it would seem logical that the hydrogen electrode should actually be used as your reference electrode, okay, for biochemical measurements. Now this type of electrodes can be built and are available commercially, like it is so these electrodes actually make use of the principle that an inert metal such as platinum which readily absorbs the hydrogen gas. Now if a properly treated piece of platinum that is partially immersed in the solution which contains the hydrogen ions and is also exposed to hydrogen gas which is passed through the electrode, and electrode potential is formed, okay, and the electrode lead is attached to that platinum. But unfortunately the hydrogen electrode that is not sufficiently stable to serve as a good reference electrode, okay, and the problem of maintaining the supply of hydrogen to pass through that electrode during a measurement, it limits its usefulness to a few specific uh, applications. However, since measurements of electrochemical concentrations simply requires a change of potential proportional to a change in concentration, these electrodes potential of the reference electrode that can be any amount as long as it is stable and does not respond to any possible changes in the composition of the solution which is being measured, okay. So two types of electrodes have interfaces sufficiently stable to serve as a reference electrode. One is silver chloride electrode, another is the calomel electrode. Okay, so in actually in electrochemical uh, measurement, the silver chloride that is this electrode is very stable. This type of electrode is basically prepared by electrolytically coating a piece of pure silver with silver chloride, and the coating is normally done by placing a clean piece of silver into a bromide free sodium chloride solution, and another second piece of silver is also placed in the solution, and these tools are connected to a voltage source that such that the electrode that is to be chlorided is made positive with respect to the other. Okay, and the silver ions that combines with these chloride ions from the salt to produce uh, deuter silver chloride molecules that coat as uh, that coat the silver chloride. Okay, but now for so this type of electrode is basically used to measure the bipotential bioelectric potential measurement purpose. In chemical biochemical transducer, with this context, the ionic side, which is the silver chloride side of the interface that is to be connected to the solution by an electrolyte bridge, usually a dilute potassium chloride uh, with solution. So this is filled with the solution with that solution, which forms a liquid junction with the sample solution. Okay, and this chloride, the electrode actually uh, that can be successfully employed as a reference electrode if the potassium chloride solution is also saturated with precipitated silver chloride. Okay, and the electrode potential for the silver chloride, for the silver chloride uh, reference electrode, it depends on the concentration of the potassium chloride. Like with a 0.01 mole solution, the potential will be 0.388 volt, and for 3.5 moles that will be uh, 0.343 volt, and uh, for 1 mole of solution the potential will be 0.236 volt. Okay, another electrode is the calomel electrode. Okay, so it is the name another name of mercurous chloride, a chemical combinations of mercury and chloride ions. Okay, the interface between the mercury and mercurous chloride, it generates the electrode potential. Now by placing the calomel side of the interface in a potassium chloride solution, and electrode uh, potential, electrolytic bridge is formed to the sample solution from which that measurement is to be made, as for just like in case of silver chloride. So so here the calomel electrode that is very stable over long periods of time, and it is served well as a reference electrode in many electrochemical measurements. Okay, and the electrode potential of the calomel electrode, it depends on the concentration of potassium chloride solution. So an electrode with 0.01 mole solution of potassium chloride has an electrode potential of 0.388 volt, and for saturated potassium chloride solution about 3.5 moles, it will be, the potential will be 0.247 volt. So this is the basic configuration of uh, silver chloride electrode or calomel electrode. Now coming to the pH electrode. So the pH of blood and other fluids is very important indicator of chemical balance, and the pH is directly related to the hydrogen ion concentration in the fluid, and it is related using this equation. So basically the pH, that is a measure of the acid base balance of a fluid, and a natural solution has a pH of 7. So lower pH number indicate the acidity, whereas the higher pH values define a basic solution. Now most human body fluids that are slightly basic type solution. Okay, the pH of normal, like the pH of normal arterial blood, it ranges between the 7.38 and 7.42. Okay, the pH of venous blood, that is 7.35 because of the extra carbon dioxide. Okay, so because of the thin glass membrane, it so here it is used, it allows the passage of only hydrogen ions in the form of hydrogen uh, H3O plus form. So a glass electrode, it provides a membrane interface for that hydrogen. Okay, so here is a diagram. So inside, look at the this diagram. Inside the glass bulb, it is a highly acidic buffer solution. So measurement of this potential across the glass interface, that is achieved by placing a silver chloride electrode in the solution inside the glass bulb, and a calomel or silver chloride reference electrode in the solution in which the pH is being measured. Okay, now to measure the pH, each of the two electrodes, it required to obtain the measurement, that is called half cell. Okay, so all of you know about the term half cell potential. I have already um, discussed about that in previous lecture. So the electrode potential for a half cell, that is that is called the half cell potential. For pH measurement, this glass electrode with the silver chloride inside the bulb is considered one half cell, while the uh, calomel reference electrode constitutes the other half cell. Okay, so here is the combinations of both a glass indicating electrode and a reference electrode. Both pH glass electrode and the reference electrode has been introduced in this uh, diagram. The glass electrode, that is adequate for pH measurements in the physiological range around pH 7, but it may produce uh, considerable error at the extremes of the range, like if it is near pH of 0 or 13 to 14. So special type of pH electrodes are available for these extreme ranges. Okay, so now modern pH electrodes, it has impedance uh, ranges from 50 to 500 mega ohm, and the input of the meter that measures the potential difference between the glass electrode and the reference electrode, it must have an extremely high input impedance. Okay, and most pH meters that employs the meter inputs. So it is another diagram of pH glass electrode. Now coming to the next electrode, which is called the blood gas electrode. So among the more important physical physiological chemical measurements, that are the partial pressures of oxygen and carbon dioxide in the blood, it should be so the partial pressure uh, of a dissolved gas is the contribution of that gas to the total pressure of all dissolved gases in the blood. And this partial pressure of gas is uh, proportional to the quantity of that gas in the blood. Okay, the effectiveness of this both the respiratory and the cardiovascular system is reflected some important parameters, like to measure the pressure of this oxygen and the carbon dioxide. Okay, so the partial pressure of oxygen, which is called PO2, that is called the oxygen tension, and that can be measured either in vitro or in vivo method. Okay, so here is the diagram of that PO2 electrode, where a fine piece of platinum or some other noble material, where that is embedded into a glass for insulation purpose, with only the tip is exposed, that is placed in the electrolyte into which the oxygen is allowed to diffuse. Okay, now if a voltage of about 0.7 volt is applied between the platinum wire and the reference electrode, which is also placed in the into this electrolyte solution. So with the platinum wire negative, reduction of the oxygen takes place at the platinum cathode. Okay, as a result, what happened, the oxidation reduction uh, current that is proportional to the partial pressure of the diffused oxygen, which can be measured. And the electrolyte that is generally sealed into a chamber that holds the platinum wire and the reference electrode by means of a membrane across which the dissolved oxygen can diffuse from the blood. Okay, and this platinum cathode and the reference electrode that can be integrated to a single unit, which is called the Clark electrode. Clark electrode. So this electrode that can be placed in a cuvette of blood for in vitro measurements, or a micro version that can be placed at the tip of a catheter for insertion into various parts of the heart or vascular system for direct in vivo measurements. Okay, so there are some problems when we need to find the pressure of oxygen. So that is, the first one is a reduction process here actually removes a finite amount of the oxygen from the uh, immediate vicinity of the cathode. So by careful design and use of proper procedure, modern PO2 electrodes that have been able to reduce this potential source of error to a minimum level. Another error, just like it is a gradual reduction of current with time, almost like in it was happened in polarization effect, which was discussed for skin surface electrode measurement purpose. Okay, and this is called generally aging. which also been minimized in modern PO2 electrodes. Okay. So this is a one type of diagram measurement of to measure the CO2, which is also called the Severingus electrode. So basically, the measurement of the partial pressure of carbon dioxide PCO2, which makes the use of the fact that there is a linear relationship between the logarithm of the carbon dioxide pressure and the pH of a solution. Okay, so here other factors also influence the measurement, which is essentially accomplished by surrounding a pH electrode with a membrane selectively permeable to the carbon dioxide. Okay, so it is a modern type of PCO2 electrode, which is called the Severingus electrode, and here the membrane, uh, permeable membrane, which is basically permeable to the CO2. It's made of Teflon. Okay, it's made of Teflon, which is not permeable to other ions that might affect the pH. The space between the Teflon and the glass, which contains a matrix consisting of thin cellophane, glass wool, or some sheer nylon. So this matrix actually serves as the support for an aqueous bicarbonate layer into which the CO2 gas molecules can diffuse. So one of the difficulties with older type of CO2 electrodes, that was the length of time required for the CO2 molecules to diffuse and obtain a reading. Okay, but here the principal advantage of the this type of Severingus type of electrode, uh, that is the more rapid reading that can be obtained because of the improved membrane and bicarbonate layer. Okay, so here's the combination of two electrodes, like PO2 and PCO2. Now specific ion, next is the specific ion electrodes. Okay, so a glass electrode, what we have seen that glass electrode, it provides a semi permeable membrane for the hydrogen ion in the pH electrode. Other materials also that can be used to form these membranes that are semi permeable to the other specific ions. In each case, measurement of ion concentration, that is accomplished by measurement of potentials across a membrane that has the correct degree of permeability to the specific ion to be, that is to be measured. Okay, so here three specific ion electrode along with a pH glass electrode has been shown over here. So the first one, which is the sodium ion electrode. So it is basically it is used to determine the sodium ion activity in blood and other physiological solutions. Second is the cationic electrode, that is to be used when studying alkaline metal ions or some enzymes. Third one is called the pH electrode basically. And fourth one, that is the ammonia electrode, which is used to determine the ammonia which is dissolved in aqueous solution. Okay, so these are ion specific ion selective electrode. Okay, so that's all for today. If you have any queries, you can ask me now.